Good morning to all of you. First, I would like to introduce myself and my teammates. I am Deepu Kumar and with my teammates Jagdeep, Aditya, Aritra and Niraj. We are here to give a present on the topic VLI processor architecture. Before proceeding further, first I would like to express a special thanks of gratitude to Sudipta ma'am who gives us the golden opportunity to present the PPT on the VLI processor architecture, which enable us to learn a lot of things. If you can't manage stress, you can't manage success. With this thought, I would like to introduce the presentation. So the presentation is on the VLI. So first I would like to give an introduction on it. So VLI refers to a processor architecture designed to take advantage of instruction level kernel, which consists of multiple independent operations grouped together. So there are multiple independent functional units in VLI processor architecture, and each operation in the instruction is aligned to the functional unit, and all functional units shares the use of a common large register file. And the main thing is this type of processor architecture is intended to allow higher performance without the inherent complexity of some other approaches. Now move to next slide. Now we talk about different approaches. Our other approaches to improve performance in processor architectures are pipeline, superscalar architecture, and out of other execution. So now I am going to discuss and give an overall meaning of the pipelining, superscalar architecture, out of other execution. So the first is pipelining, breaking up instruction into sub-steps so that instruction can be executed partially at the same time. That is the meaning of the pipelining. And the second is superscalar architecture, dispatching individual instructions to be executed completely independently in different parts of the processor. That is the overall meaning of superscalar architecture. And the third, but not the least, out of other execution, executing instructions in an order different from the program. That is the meaning of out of order execution. Now, move to the next slide. Okay, thank you, Deepu. Now, in this slide, we are going to discuss about ILP, which is basically stand for instruction level parallelism. Instruction level parallelism is a measure of how many of the operation in a computer program can be performed simultaneously. The overlap among instruction is called instruction level parallelism. Ordinary programs are typically written under a sequential execution model where instructions execute one after the other and the other specified by the program. Goal of compiler and processor design implementing ILP is to identify to take advantage of as much ILP as possible. Next slide. Okay. Here is an example of ILP. Consider the following program: operation 1 E equal to A plus B, operation 2 F equal to C plus D, operation 3 M equal to C multiply F. Operation 3 depends on the result of operation 1 and 2, so it cannot be calculated until both of them are complete. However, operation 1 and 2 do not depend on any other operation, so they can be calculated simultaneously. If we assume that each operation can be completed in 1 unit of time, then these three instructions can be completed in a total of 2 units of time, given an ILP of 3 by 2. Next slide. Okay. Now we will see VLIW compiler. Compiler is responsible for static scheduling of instruction in VLIW procedure. Compiler find out which operation can be executed in parallel in the program. It groups together these operations in single instruction, which is the very large instruction one. Compiler ensures that an operation is not issued before its operands are ready. Next slide explained by Aditya.
So whatever instruction we give to the computer by programming, these instructions are like add, subtract, multiply, bitwise and bitwise or load store, etc. These are small instructions. Small in the sense that they called small instruction size. Instruction size, instruction size is contains of code and operands, right? Now let's think what will happen if instead of instruction of a small size, we use instruction of larger size. From size, I mean 64 and above for 64-bit or 84-bit computers. Then what kind of instruction would it be? This instruction is like the CPU can execute it at once. But now I just said that larger instruction and then I said CPU will execute it at once. How? Let's see. We know CPU components are ALU, memory unit, control unit, right? So what we can think of is why not use an instruction so that one of the instruction part um, of the instruction is executed by one of the component of CPU and other parts of this instruction is executed by other components of the CPU. So what we can think of a various processes to be carried out, various processes of the instruction to be carried out by various components of the CPU. One thing to note here is that, next slide. So one thing to note here is that where IW systems is not necessary that CPU contains just one of the components, which I just said the names like memory unit, ALU, or others. Like there are one CPU and more than one functional units, like two ALUs, or I must say more than one ALU, more than one memory unit. Now consider this instruction. It has add R1, R2, R3 registers, subtract R4, R5, R6 register, load data from R7 and store data in R8. So as I just said that VLW systems can have more than one ALUs. So for a CPU containing two ALUs, these two operations are to be carried out simultaneously at once, and 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 these the other two instruction parts are load and store time. So we have no ALU left to perform these operations. So these operations have to be carried out by memory unit. So what we can see is that uh, various parts of the instruction are carried out by various components of the CPU at once. So process goes on simultaneously in the CPU. Next slide. This block diagram explains VLW architecture. Now Aritra will continue.
So thank you, Aditya. So now let us look into the working of this VLW processor. Now how it works. So at
Next
first,
slide.
yes, it's okay. Next slide, go to the working portion. Now at first, all instruction words are fetched from the memory, where a common multi-ported register file is there for fetching the operands and storing the results. Parallel random access to the register file is possible through the read or write crossbar. Next, the execution in the functional units is carried out concurrently with the load or store operation of data between RAM and the register file. One or multiple register files for FX and FP data, where it relies on compiler to find parallelism and schedule dependency-free program code. Next slide. Some of the examples of VLW processor are VLW mini supercomputers. Next is single chip VLW processors. The third one is single chip VLW media. like trimedia, chromatic, microunity, and the last one is DSP processors. Next. Now, advantages of VLIW are dependencies are determined by compilers and used to schedule according to function unit latencies. Function units are assigned by compiler and correspond to the position within the instruction packet. It also reduces hardware complexity, like tasks such as decoding, data dependency injection, instruction issues, etc. become very simple. It ensures low power consumption and also it ensures potentially higher clock rate. Now Jagdeep will continue the next program.
Thank you, Aritra. Disadvantage of VLIW processor: higher capacity of compiler capability across implementations. Compiler optimized needs to consider technology dependent parameters such as latency and load use time to catch. Unscheduled event stall entire processor. Code density. Code density in case of unfilled of code in a VLIW processor, memory space and instruction bandwidth are wasted. Low slot utilization. Code expansion cause high power consumption. Next slide. Application. VLIW architecture is suitable for digital signal processing application. Processing of data like compression, decompression of image and speech data. Thank you for listening.